Chapter 8, Part 2. Chapter 8, Part 2, page 274. Chapter 8, Part 2. Proposed mechanisms by which plyometric training enhances performance. Proposed mechanisms. There are several proposed mechanisms by which plyometric training improves performance. Enhanced muscle spindle activity. Desensitization of the Golgi tendon organ. Enhanced intramuscular and intermuscular neuromuscular efficiency, increased strength, improved muscle activation, and better muscle coordination. Those are the mechanisms. Enhanced muscle spindle activity. Enhanced muscle spindle activity. The speed of a muscular contraction is regulated by the neuromuscular system. The human movement system will only move within a set speed range, regardless of how strong a muscle is. The faster the eccentric loading, the greater the concentric force production. Therefore, the quads are loaded more rapidly when dropping from a 1 meter box versus a 0.25 meter box. It's lower. Okay. Desensitization of the Golgi tendon organ. Desensitizing the Golgi tendon organ increases the stimulation threshold for muscular inhibition. This promotes increased force production with a greater load applied to the musculoskeletal system. Enhanced neuromuscular efficiency. Enhanced neuromuscular efficiency. Plyometric training may promote better neuromuscular control of the contracting agonists and synergists, thus enabling the CNS to become more flexive. These neural adaptations lead to enhanced neuromuscular efficiency even in the absence of morphological adaptations, such as muscle hypertrophy. Exploiting the stretch reflex, inhibiting the Golgi tendon organ, and enhancing the ability of the nervous system to react with maximum speed to lengthening the muscle optimizes the force produced by a concentric contraction. Exploiting, page 275, exploiting the stretch reflex, inhibiting the Golgi tendon organ, and enhancing the ability of the nervous system to react with maximum speed to lengthen muscle optimizes the force produced by concentric contraction. No commas. Increased strength. A meta-analysis from Viril demonstrates that plyometric training has a positive effect on development of strength. Plyometric exercises can assist both trained and untrained individuals in developing more strength. An individual training status should be taken into account when determining overall volume of plyometrics, but supplementing strength training with plyometrics for athletes helps maximize strength gains. Additionally, there appears to be a maximum training threshold within the volume of plyometrics that, once reached, will yield no further strength gains, so you'll hit a wall. Improved muscle activation. Improved muscle activation. When compared to a squat jump, a counter movement jump has been shown to produce more explosive force. The counter movement occurs just before the jump. Dropping down into a deeper squat immediately before exploding up is the counter movement. Improved muscle activation. The loading of the jump through the counter movement itself allows for the maximum activation of the concentric muscles. Activation of these muscles allows for the development of maximal strength by activating all availability. Activation of all these muscles allows for the development of maximal strength by activating all available muscle fibers, leading to the explosive nature of plyometric exercise. By activating muscles through the plyometric movement, more force can be developed to maximize the effectiveness of these techniques. Improve muscle contraction. Improve muscle contraction. As with any movement, the coordination of musculature is vital to the performance of plyometric activities. It has been demonstrated that plyometrics not only improve the synchronization of motor units, but also improve the ability of the athlete to perform the movements. It is believed this is caused by the forces developed through plyometric training, as well as recruitment of larger motor units through the myotic reflex. Plyometric training has been shown to be effective in developing coordination of muscle fiber recruitment, ultimately assisting with performance enhancement, improved muscle coordination. Plyometric training has been shown to be effective in developing coordination of muscle fiber recruitment, ultimately assisting with performance. So you're probably recruiting more muscle fibers. In the end, plyometric training has wide-ranging effects beyond power output. There is moderate evidence that when plyometric exercises are incorporated into an integrated training program, there are documented improvements in jumping ability, running economy, agility, power output, and rate of force development, but not strength. When used in an isolated training program, there is moderate evidence that plyometrics have few positive benefits on performance. Thus, the rationale for its incorporation as part of an integrated, holistic program. Plyometric training parameters. Exercise selection. Safe. Done with supportive shoes. Performed on a proper training surface. Grass field, basketball court, tartan track surface, rubber track surface. Perform with proper supervision. Progressive, easy to hard, simple to unknown, simple to complex, known to unknown, stable to unstable, body weight to loaded, activity specific. Variables, plane of motion, sagittal, frontal, transverse. Range of motion, full, partial. Type of resistance, medicine ball, power ball. Type of implements, tape, cones, boxes. Muscle action, eccentric, isometric, contraction, concentric. Speed of motion, duration, frequency, amplitude of movement. Page 277, chapter 8. A systematic and progressive plyometric training program is a vital component of an integrated training program. As plyometric training is one of the more advanced training tools, the athlete needs proper levels of flexibility, core, and balance before progressing into plyometric training. Sports performance professionals must follow very specific programs, guidelines, proper exercise selection criteria, and detailed program variables for the best outcome and lower risk of injury. Lowest risk of injury. As with all training programs, overload will need to be considered. Increasing stretch load increases intensity. This can be accomplished by using body weight over a greater jump distance, or drop height. Progression from 2-leg to 1-leg jumps also increases intensity. As the athlete progresses, the duration of the amortization phase should be as brief as possible. The number of foot contacts monitors training volume. The more contacts, the greater the training volume, as well as always, training volume is inversely related to training intensity. Partach and Chu. These are citation. Offer the following suggestion for a single training session. A low intensity training equals 400 foot contacts. Moderate intensity training, 350 foot contacts. High intensity training, 300 foot contacts. Very high intensity, 200 foot contact. So you're getting less and less between foot contact. Experience should also be considered when prescribing plyometrics. Athletes with maximal experience using plyometrics should keep the ground contacts to less than 100 maximal efforts per session. Those with considerable experience could have as many as 120 to 140 maximal effort ground contact per session.